morning, everyone. It's great to be here. And I would like to ask you to think about your everyday life. You wake up in the morning, maybe you had a headache, you took some pills, you prepare yourself a cup of coffee, and then you washed it with some soap. Then most of the majority here went to the mirror, maybe put some makeup, some perfume. And then you went to the lab. Maybe you're dealing with some plastic medical devices. And then you drove your car that sometimes need to have supplements in it. And you ate something which have some food preservatives or additives. All of those things around us that makes our life easier and nicer and makes us happy are actually chemicals. And more precisely, they're chemical products. And I would like to talk about a specific product. It's called a specific chemical. It's called propylene oxide. It's a small molecule which has 3 carbon atoms and 1 oxygen atom. And why I want to talk about propylene oxide? Because the propylene oxide is actually the starting point of all of those things that we daily use. Most of them, not all of them. It's actually the building block for these materials. And the thing with the propylene oxide that currently it's been produced in factories, and mostly in the production of propylene oxide is polluting and environmentally harmful. And what we do in our lab, in Newman's lab, we try to make these kind of processes more green, more environmentally friendly, to the benefit of all of us, of course. So let's take this propylene oxide molecule. Let's think of it as a prince, and we want to get the prince. But the thing is that all of us know that to get a prince, we need to kiss an ugly frog, right? And the ugly frog is our starting material, which is propylene. Okay, it's a 3-carbon molecule with a double bond. So what I actually want to do is to get an oxygen bond, an oxygen atom, to bond with the propylene to get the propylene oxide. This thing so far has been done by the Wicked Witch. She puts in some toxic starting ingredients, and she produces polluting byproducts that we don't want. And we would like to avoid that. So we thought about it with a professor and with Ronnie, and we thought, how can we make it? And we came up with an idea to use water. Water are benign, it's a small molecule, we all know it. We can get it everywhere. And it has 1 atom of oxygen that we can combine with your molecule. So let's say that the water molecule is actually a nice princess. But how would the princess get to the frog to kiss it? The princess lives in a kingdom far, far away. How will she get to the frog? So in our lab, what we use are catalysts. What are catalysts? It's actually a substance that we use in a small amount that helps us do the reactions much faster. It's in a professional language, it's lower the activation energy for the reaction to happen. So in our story, it's actually bicycles. But our princess, she's a princess, she's high class, she won't ride the bicycles, right? So we want to give her kind of a boost. Let's think of electric bicycle, right? It's kind of trendy now. So how do we give energy to the bicycles to become electric? Just in real life, we use electricity. We use electrochemistry in our lab. We apply an electric potential on the catalyst to do its work. And you know today that electricity can be acquired in sustainable green ways through renewable sources like the sun, for example. So we apply the electricity on the catalyst that actually activates the water. Okay, it takes the water, our princess, and rushes to the frog, and actually it activates the water. The water will react with the propylene to get a propylene oxide. So this is, it's not a fairy tale, okay? Maybe it sounds like it, but it's not. This is an actual reaction that happened in our lab about 2 or 3 weeks ago, which made me very, very happy because this is my PhD project. And I worked for it very hard for the past 4.5 years. And not just that we managed to do this reaction in a greener way, we also didn't produce CO2, which was great. I do get some other byproducts, but in the coming weeks till the end of my PhD, this is what I'm working on to make it more selective towards the propylene oxide. And so this is the one thing that makes me very happy, that it actually worked. The second thing is that I know this is a small contribution to our everyday life, that we can use those materials, those substances that we like, that help us, without feeling guilty that they are harmful to the environment. And as someone smart used to say, and you know that we are all material girls and boys, but I would like to paraphrase that and to say that we all want to live in a sustainable world. Thank you very much.